Okay, chapter 1-6, practice A and B, 26 through even, 44 through 52 even, check your answers, and 58 through 66 even. Whenever I say check your answers, what does that mean? No, plug and chug back in. Now, these are all evens, so the evens are not in the back of the book. And we all understand that. The evens are not in the back of the book, only the odds are. So you guys need to make sure that you are checking odds in the back of the book, but the evens, you're going to take the answers in class. Any questions over what I just said? Okay. Now, I printed this off for you guys. I printed off the first 2 pages so that you guys would be able to have it sticking out right in front of you while you're doing your homework assignment for tonight. I just passed those out. Does everybody have it? Yay or nay? Those of you who are still needing to copy that. Today what we're talking about is absolute value inequalities. When we're dealing with inequalities, we always have to be very, very careful about when you flip the inequality symbol. So one of the questions that I asked you on Edmodo the other day was, when do you flip the sign? Many of you put when you divide by a negative. Is that the only time you flip the sign? When is the time that you flip the sign then? When you multiply or divide by a negative. So division is not the only time that you flip the sign. It's whenever you multiply by a negative that you must flip the sign also. Do we all understand that, yes or no? Excellent. Now, what I want you guys to do is pretend that the inequality statement is actually an equation. And you're going to still have case 1 and case 2. Do we all understand that? So nothing has changed. Now, solving steps in solving absolute value inequalities. Number 1, isolate the absolute value. You're going to get rid of every single thing that's attached to the absolute value if it helps you. Okay? There's going to be times where it's not going to be very helpful because do you like to deal with fractions? No, if you don't like to deal with fractions, do you really want to get rid of a number that's attached to it then? Probably not. So step 2, determine if the absolute value is even possible. In other words, are you going to take the long, windy road, plug and chug and find out that the answer does not work, or are you going to look at that and make common sense logic skills and say, oh, well, no, that cannot be true because a positive can never be less than a negative, right? So look for those. Then you're going to do case 1 and case 2, then you're going to solve each case, and then you're going to do number lines. And the reason why you have to do number lines today is because number lines indicate regions, okay? Yesterday's and Mondays, we were talking about solving equations with absolute values in them, which meant it was one specific answer or 2 specific answers. Does that make sense? Tonight, we're talking about doing inequalities, and inequality deals with a region of answers. Do we get that, yes or no? Well, you guys are asleep. Now, moving right along, we're going to start right off in the section of homework. So I'm going to do problem number 25, which is not a homework problem, I understand. However, it is one that I felt that we need to start off with. Do we all understand what I just said? So number 25. Step 1 says to do what with your absolute value? To isolate it. So where's my absolute value? My absolute value is right here. And what's attached to it by what operation? The 3 is attached by multiplication. So how do I get rid of it? Divide, because we want to isolate. So isolate means we need to get rid of that 3 and put it on the other side. The way we're going to do that is by dividing by 3. But the question I have for you is, do I really want to divide by 3? The only way I can determine if I want to divide by 3 is I need to look across the equal sign and say the number across the inequality symbol here is 27. Is 27 divisible by 3? Yes, it is. Since 27 is divisible by 3, would it benefit me to divide both sides by 3? Yes. What if it wasn't divisible by 3? Would you want to divide then? No, because then you'd be dealing with an ugly fraction. It'd be like ugly fractions. No. So what we're going to do is we are going to divide by 3 because 27 is divisible by 3. Do I flip the sign? No, because I didn't divide by a negative, and this is going to give me 9. So now the next thing I need to do after I've isolated my absolute value sign is now I need to determine if this is even possible. So what does that mean? So that means the absolute value, this whole thing, has to be positive because what do we know about absolute value? It is a distance, and distance can only be measured in positive units, so therefore it has to be a positive outcome always. And can that positive outcome be less than a positive number? Well, tell me this, is 25 less than 100? They're both positive, aren't they? So is this a possibility? Does this possibility exist? Yes, so therefore, since I know it's possible, I have to immediately go into case 1 and case 2. So case 1, I'm going to have what? I'm going to have y minus 9 is less than 9. Excellent. What's case 2? Negative times y minus 9 is less than 9. Do we all see that? Yes or no? We good? Okay, moving right along. What do I do? What is y minus 9 less than 9? How do I solve that? Add 9 to both sides. Y is less than 18. There's my first region answer. Go to the next case. What do I do? Distribute. So that's negative y plus 9 is less than 9. Subtract the 9. Negative y is less than 0. And now what do I do? Why do I have to divide if it's 0, though? Okay, but 0 divided by anything is 0, so can I just ignore it? So I can just ignore it and say y is less than 0 and I'm good to go? Why do I have to flip the sign? Because even though my brain is doing it automatically and saying that 0 divided by anything is 0, that is a true statement. However, because I did not flip the sign, I would be wrong. So this is actually going to be y is going to be greater than 0 because I divided by a negative 1. Do we all understand that, yes or no? So this is where you need to make sure you're following your logic all the way through. Now, if you go back to your steps say to now we solved each case, so what do I need to do for step number 5? Do my number lines. So I need to do my number lines here. So I need to have a number line for each answer, and then a number line for my last answer, the final answer. The reason why we have to put these on a number line is because we want to know if these two number line regions are going to overlap, meaning they are a what? An and, or that they are going to go in opposite directions, meaning they are an or statement. So which one's smaller, 18 or 0? 0 is smaller, so I'm going to put 0 on the number line first on the top. And is it greater than or less than, opened or closed? It is open because it is strictly greater than, and I'm going to shade to the right. Now, the next one is going to be 18. 18 is to the right of 0, and I'm going to put that to the right on the second number line. And is it opened or closed? It is going to be open, and which direction do I shade on that? To the left. Now, what do you see happening with these two number lines? They overlap. So what we're going to do is we're going to put them on one number line together. Here's 0 and here's 18. They're both open, and where do they overlap at? In the middle. Okay, good. I want you to draw on 2 separate lines so that you can physically see it. If it's going to kill you to do that, by all means, you can change it up, but you better not make it wrong. Okay? So now, this is my answer. How do I write that answer algebraically? Remember, this was the trapped ping pong ball between the walls. So, Melissa, what do I do?
Y is greater than 0.
Nope. It's an and statement. But an and statement means we write it as an inequality as 1. I don't want you to.
I think y is.
Nope. Sarah? She's absolutely right. You put your walls up, you put your y in the middle, because that's where y is at. It's trapped between your walls of 0 and 18. And what is the relationship between 0 and 18 always and forever? 0 is always less than 18. And because they're both open dots, I leave them as the strictly less than sentence. Do we all understand that? So if you write this as an and compound inequality, of saying that y is greater than 0 and y is less than 18, I'm going to mark it wrong because you have not given me the actual big boy, big girl notation. We understand that. Okay, moving right along, number 28. Number 28, this is a homework problem. Step 1 says to do what, folks? Isolate your absolute value. So what's attached to the absolute value? The 1/4 and the +2. What do I get rid of first? I need to get rid of that +2 by subtracting 2 from both sides. So 1/4 times the absolute value of x minus 3 is less than -1. Again, I'm isolating that absolute value, so what else is attached to it? 1/4. How is it attached? So how do I get rid of it? Divide by 1/4. When you divide by a fraction, multiplying by the reciprocal. So I'm going to multiply both sides by 4. Do I flip the inequality symbol? No, because why? I did not divide or multiply by a negative. So these are gone, and I'm left with the absolute value of x minus 3 is still less than -4. Now, after I've isolated my absolute value, what do I need to do? I need to check if it's even possible, so continue. She's saying that this outcome right here has to be positive, and it's saying that it's going to be less than the outcome of a negative value. Can a positive number ever be less than a negative number? No, so therefore, is this even possible to do? No, so I have no solution. Do we understand that, yes or no? Make sense? Okay, next, number 30. Number 30.
Absolute value is always
The stuff that's inside the absolute value, x doesn't necessarily have to be positive, but the x minus 3 together has to be a positive when you take the absolute value. Does that make sense? X could be -5. -5 and -3 can be -8, and the absolute value of that is 8. Does that make sense? Okay. Good question. Number 30. Number 30. Step 1, what do I do? I need to isolate my absolute value, so I'm going to go ahead and subtract 9 from both sides. And I have 3 times the absolute value of 5t minus 1 is less than or equal to, what's 23 minus 9? 14, correct? And you might want to check that considering what I did on the first example. Okay, now what? I'm still isolating. So how would I get rid of that 3? Divide. Do I want to divide here? Why do I not want to divide both sides by 3? Because 14 is not divisible by 3, and it's going to give me a fraction. And do we like fractions? No. So what we're going to do is we're going to say, is this even possible? So 3 is a positive outcome, and I'm going to multiply that by a positive outcome, and that has to be less than or equal to a positive number. Is it possible? Sure, it is possible, so therefore I have to do case 1 and case 2. So case 1 gives me 3 times 5t minus 1 is less than or equal to 14. Case 2 gives me -3 times 5t minus 1 is less than or equal to 14. Do we all see that, yes or no? Okay, so what do I do here? Distribute, so 15t minus 3 is less than or equal to 14. Come on. Add 3 to both sides. 15t is less than or equal to 17. Divide by 15. Do I flip the sign? No, so t is less than or equal to 17 over 15. Now what do I do? What do I do? Distribute. Negative 15t plus 3 is less than or equal to 14. Subtract 3. Negative 15t is less than or equal to 11. Divide by negative 15, and what happens? Flip the sign to greater than or equal to.
That would be really loud.
Do we all understand that right now? Okay, so now that we've done that, what do I do now? Why do I not plug and chug? Because it's a region, right? I'm looking for regions. So I need to do a number line, and I need to have 3 number lines because I have 2 answers, and then I have my final answer. What's my smallest value? Negative 11/15. And is it opened or closed at negative 11/15? It is closed. In which direction do I shade? To the right. Go to the next one. Which one's my next one? 17/15, and that's going to be my larger one. It's closed, and I'm going to shade to the left. Now, what do you notice? They overlap again. So therefore, I have negative 11/15 and 17/15. They're closed at both of them, and my shading is in between. And how do I write that in big boy and big girl notation? Actually, stop. Somebody else other than Sarah. Sorry, you had it last time, and you clearly understand it, so good job. Somebody else. Haley? Less than or equal to? T.
Right now, less than.
Less than or equal to 17/15. Why do they both have to be less than or equal to? Because if I take out that t, I always have to have a true statement. And negative 11/15 is always less than 17/15. Do we understand this? The arrows have to be pointing to the left. They have to be. Okay? Okay, number 66. Always put the small. Okay, number 66. Step 1, what do I do? Isolate. So what's attached? The -3. So how do I get rid of that? Add 3 to both sides. And I have the absolute value of x plus 5 over 3 is going to be greater than 9. Next, what do I do? Randy? I cannot multiply it by 3 on both sides. Why can I not multiply by 3? Because the 3 is inside the absolute value bars. So you cannot do that until you do case 1 and case 2. Before I do case 1 and case 2, what do I want to do? See if it's possible. Can this outcome of a positive be greater than a positive number? Yes. So now that I know it's possible, what do I need to do? Case 1, case 2. So what's case 1? X plus 5 over 3 is greater than 9. And what's case 2? Negative x plus 5 over 3 is greater than 9. Now, if I solve case 1, how is that 3 attached to the x plus the 5? So how do I get rid of it? You multiply both sides by the value 3. So if I multiply by the value 3, do I flip the sign? No, I don't. So that gives me 27. Now what do I do? I need to subtract 5. So x is greater than 27 minus 5 gives me 22. Now, case 2. Where does that negative go? Clinton? You could distribute it to the numerator. You're absolutely right. But that means I have possible errors, because what if I didn't distribute it to both terms? So where else could I put it? I could put it in the bottom and not even change the top and make that -3. Do we all see that? That's what I would do every time. I would put it to the bottom so that it's less work for me in distributing. Do we all understand that? So now how do I get rid of that -3? Multiply both sides by -3. And what happens when you multiply both sides by -3? We flip the sign, and I'm going to get -27. Less than -27. Now what? Subtract the 5, and I'm going to get x is less than -32. So now you tell me which one's smaller, which one's larger. -32 is smaller. So I'm going to go ahead and put that on the top line. So I have -32, and now I have it opened or closed. It is open. In which direction do I shade? To the left. The next one is going to be 22. That goes over here to the right of it, and it is going to be open. In which direction do I shade it? To the right. Now, what do you notice about these? It's an or statement, because what's happening is they're going in different directions. Now, how do I write an or statement correctly? Which direction do I read it from? Left to right. So x can be less than -32, or x can be greater than 22. I want you to read it from left to right, because we always work things in mathematics from left to right. Any questions over what I just taught you today? Do we all know what our homework is? You already got it on the top of the first slide, and it's also on the board over there. Now, with that said, tomorrow you are going to have a chapter 1-6 quiz over practice exercises 10 through 24 all, and that was the equation part. Do we all understand that, yes or no? We good? Okay, we're out of here in 5 more minutes, so I expect you guys to actually do homework and not sit there and talk or anything else. I want it silent in here. Any questions over what I just said? Okay.
Carol, no, we're done.